much for your presentation. I see that Mario is now also live with us. What time is it at your place?
Sorry?
What time is it at your place?
We have now 6:15 in the evening. So good evening.
Oh, that's okay.
That's okay still, yeah.
Okay, are there questions? Marcel. I will allow Marcel to talk. Hello, Marcel.
Hello, does this work?
Yes, it works fine.
Is it on? Yes, okay, great. Hi, Mario, a great talk, and I think it was really cool work as always. I think I might have missed it in the talk, but what exactly is the training and test set size for all the losses that you report in the end?
So the overall test set size is 600 points.
Okay.
And then we have to do this additional split because we optimize the domain of applicability. And then we cannot use the data that we use to optimize the domain of applicability to estimate the performance on that domain anymore, in the same fashion as it would not be unbiased to assess the model performance globally on the training error.
Yes.
So we do another split where we use 500 training points, or test points, I should say, to optimize the domain of applicability. And then we have 100 points left to get an unbiased performance estimate. So the 100 points we have in the end. But okay. Also what we are doing is another cross-validation step. So we're actually repeating that process 6 times to get an average value.
Okay, and do you have a sense how this, if you just do it randomly without any domain of applicability, how that influences the errors? Because of course, I mean, if you just randomly happen to pick a really small test set and you get lucky, right? You also have really low losses without having any actual improvement in your method.
Well, so the model is fitted already once. So we don't, if you just pick a random test point, you don't necessarily get a better performance there, right? So on average, you get the average test error that you know, but you don't refit the model. So therefore, it is not true that if you would just pick one point, that you would have 0 error all of a sudden. That would only be the case if you would refit the model.
Okay, now I think I'm just curious to see, like, in exactly the same setting, how much the improvement in losses. You know what I mean? And I'm pretty sure the average error will just converge to exactly the same value if you have 600 points or you just use 100 and you do it 6 times, right? But I'm just curious if that's actually the case.
Yeah, so I'm not 100% sure I understand fully the question, but so one thing I can say is that on average, if you would pick random points, then you would get the global test error.
Yes.
And that is what we see in the gray, or what we saw on the slide. I probably doesn't make sense time-wise to try to bring that up now, but that would be the gray histogram. That's the overall error distributions that we have in the test set. So you draw, if you would draw individual points, you would end up somewhere according to that distribution.
Okay.
And then once you restrict the domain, like in this systematic way, then you get these blue distributions.
Okay.
And the overall shift in expectation, so that's what we plotted in the table. So for instance, for MBTR, you get this factor of 2 reduction.
Okay.
Over this, what you expect when you draw random test points.
Okay, nice. And this is the Kaggle test set, right? Like the same.
This is all the Kaggle test set. So that's all the publicly available test data.
Okay. All right. Thank you.
Thanks a lot for the question. In the Q&A from Aleftina. How long it usually takes to make the whole loop of testing training? Is it days, weeks of computing?
So actually I had to ask my co-author Chris Sutton now when it comes to the fitting of the models. I'm not 100% sure, but I know that the fitting of the models is the bottleneck usually in this case, and also the computation of the representations, depending on how these representations have these hyperparameters also. So depending on how you choose them, you might get more expensive computations there. As far as I recall, for the model fitting, we talk about potentially days. But that is a bit with a, please take that number with care. But what I can guarantee is that the domain of applicability fitting on that data set, that is much faster. So that is essentially can be integrated into the usual test workflow, because you actually have to compute the test errors anyway. So that gives you your labels that you use for the subgroup discovery. And then the subgroup discovery itself can be very fast, but here also I have to put in a word of warning. That also strongly depends on how many of these basic propositions, of these basic statements you put in to formulate the conjunction that gives you the ultimate domain of applicability. So we kept that relatively small by using these 10 features of the unit cell, and then have various thresholds there. So we are in the order of 100 plus basic propositions, and then this is actually a matter of a couple of minutes, the fitting of the domain of applicability.
All right.
Yeah, thank you very much.